Okay, as a quick reminder, this is the review. This is not this is just a very quick final review of the chapter. If this is the first time you're going through the material, you should go back and watch the first one of the recording of chapter 3. But this is just as quick so we can run through this. It's a time for us to make sure that we got all the information. And if there's something that jumps up that we don't remember, don't know, we know what we need to study. So here we are jumping into chapter 3. Okay, so when we're talking about chapter 3, the book starts out and it explains that the first two chapters were very detailed, very technical. We have to be because when we're talking about what does the cloud do, and then we go into talking about our networking and our storage, those are very technical in nature. So, no way around getting through those two technical things. But what the introduction here is telling us about is from this point forward, we're talking about things more from a business perspective. So there's still a little bit of technology, but this is the stuff that everybody understands. You know, like from here on out, the people that we're talking to aren't going to understand the hypervisor. They're not going to understand the underlying infrastructure that makes our cloud systems work. We're going to be a little bit more high level, and we're thinking about things from the business perspective. So, in chapter 1, we talked to principles of design. In chapter 2, networking and storage. And then now we're going to jump into this chapter where we're talking more about using cloud assessments and then understanding cloud services, again, from an end user perspective. So, when we're talking in our first section about using cloud assessments, we're going to learn how to gather current and future requirements, talk about our key stakeholders, asking the right questions, running a feasibility study, conducting a gap analysis, using reporting, understanding benchmarks, and creating documentation and diagrams. And when we're halfway done with this chapter, then we'll talk about the of what we're going to learn about in the understanding cloud services. All right. So this first section is the first 10 pages of the chapter, 79 through 70 through 89. And it's all around the concept of using cloud assessments. So when we're doing cloud assessments, what we're doing is we're trying to look at the world of cloud and make decisions based off of business needs, not based off of what we want or what things that we think we might need. So we're wanting to use an assessment so that we can make an unbiased decision on what type of cloud to go with, what do we migrate first, and in the different areas that we look at. So again, from a purely business view. So, what we're going to talk about throughout this next section is gathering current and future requirements, key stakeholders, asking the right questions, running a feasibility study, conducting a gap analysis, using reporting, understanding benchmarks, and creating documentation and diagrams. So, first of all, using cloud assessments. So, if you search the internet, you're going to find dozens of different frameworks for cloud assessments and migrations. Each major CSP and cloud consulting agency seems to have their own framework, and we'll be exploring some of the major ones. At first, it can seem overwhelming, but really and truly, what it is making sure that you have a criteria and a way to work through it, that everybody's talking the same language, everybody's working together, and that everybody understands the big picture. So the word framework, that's really been, I don't want to call it a buzzword, but I would say over the last 7 to 10 years, no, maybe not even that far, but at least over the last five, especially when with cloud getting bigger and bigger, the word framework has really taken over in the industry. And the things that we think about when we're talking about a framework, it's like a rule book and a process book, and it's a way to make sure that we know what phase we're in, what the task of those phases are, what it requires to move on to the next phase. So here in our cloud implementation framework, simply put, we're gathering requirements. We're going to do an assessment, then we design, we implement, and then the final section there is called operations and management. So when we gather requirements, this is our business requirements, technical requirements. This is where we define our key stakeholders. And then in our assessment, we have baseline, feasibility, gap analysis, And a baseline is very, very important because when you talk about a baseline, you can't just assume that you'll be able to tell when things are better or how things are working. You have to be able to prove it. So the best way to do that is to set a baseline. And then that way you have something to compare it to. And then also when you're doing scheduling, you want to set a baseline schedule so that you know if you're ahead of schedule or behind schedule. Then when we move into our design, this is where we define what the future state is going to look like. And we have a lot of architectural diagrams, and we ensure that we are moving towards a goal and that we know what that goal looks like when we get there. And then our implementation, this is usually when we migrate. This is when we go from the old world into our cloud world. And then operations and management. This is what we do at the end. This is once we've implemented everything, we want to sit there and watch everything and make sure that we hit the mark with what we were going to, and then close out our projects and close out those activities. Again, this is all around the cloud implementation framework. And depending on where you work, this could look very similar to this, or it could be something a little bit different, but it's going to have these types of steps and these types of goals along each step of the way. All right. So then some of the things that we look at when we're saying we're using our cloud assessments. Does our business need the cloud? Is part of our business already in the cloud? What services are we exploring? What do we need? What are the requirements? Who are the key stakeholders? Who has a vested interest? What is their motivation? How much influence do they have? So let's break these down and take a look at this a little deeper. Who are the key stakeholders? So everyone thinks they're a stakeholder, but really there's just certain people in the company that are stakeholders. And usually they have a C in front of their name, or at least department managers, directors, but like our CEO, our CFO, CIO, CTO, our chief information security officers, and again, department managers and key network and application users. So what we're looking at here is what types of questions should we be looking at whenever we're deciding what's important to us and what is going to help us migrate into our cloud environment the best possible way. So we want to ask some of the right questions. This is where it's important to have the language down. And remember, I was telling you about how you don't want to be stopping and thinking and going back and doing research on what some of these concepts are. You need to be able to speak in these terms so that everyone in the room, when you say we're talking about an infrastructure as a service, that everyone in the room knows what that means so that you can have those types of conversations and not have to go back and define those conversations. So, quick reminder, infrastructure as a service. This means that I have my big three items taken care of. I can do compute, meaning I can install, deploy virtual machines. I can do my memory and storage. Sorry, I didn't mean memory, I meant storage. I can do my storage. I know what I have for object level storage. I know what I have for my file system. And so I can have virtual machines, storage, and network. So remember, if you have those three things, you can replace the data center. That's the concept behind infrastructure as a service. Platform as a service takes it a little bit farther. And what platform as a service says is that I have all of those things I just mentioned, but I also can implement some pieces of the cloud that's going to be a managed service that somebody else is going to manage. The CSP is going to manage themselves. So it's more like deploying servers that you don't have to log into and operate and upgrade the operating system and do all those things. You're implementing these services that put a little bit better layer on top of that infrastructure. And then, of course, we have software as a service, which means you're going to deploy software packages and use them as they are, meaning that you're never going to have to do anything with it. And I always use the example of Google Mail, Google Sheets, Google Docs. Those products are out there. We make a few clicks and we're using those products. We have no idea where they're running. We don't know what server they're on. They're just there and they work. So these are the kind of questions when we're doing an assessment. What pieces of this, and it could be different answers to decide on what pieces we're doing. But are we wanting to do an infrastructure as a service deployment, platform as a service or software as a service. Other questions, what type of framework are we going to use? If you're going to go into Amazon, you're probably going to go to Amazon and look at their framework and use it. If you're going to go into Azure, you might want to look at that Microsoft framework. Google, same thing. Go to the Google framework. So you explore and you determine what rule book are we going to use, what plan are we going to use, and what framework we're going to use. And then finally, we're going to look what CSP. This is a bigger question than you would think. There's different reasons for why you want to use which CSP. I have a biased opinion. I've shared it with you before throughout this course, but you need to learn what each of these CSPs are good at so that you can come up with your own opinion and use cases for which CSPs are the best ones to use. So other questions we might want to ask, who is paying for the migration? So, that has a lot to do with who is a key stakeholder. The people who are paying for it are the ones that are going to probably have the most that they want to say about it and will want to be able to put what they desire into the plan. So that's very important. Others, what are the company's needs right now? So this is easier in the cloud. The commitment's easier than on-prem. So what I'm saying here is, if you're ordering a piece of hardware for your data center, we've talked through this before. That can be a very lengthy ordeal. You have to define exactly what kind of server you need. And you don't just look at what you need. You say, what am I going to grow into? What type of commitment am I wanting to make here? Do I need to purchase a server that I want to be using 5 years from now, 10 years from now? What am I needing to buy? And then whenever you decide to purchase it, you buy it, you bring it into your data center, rack it, stack it, then you install the operating system, then you install the applications. It's a tremendous commitment, very expensive. You pay all up front. Now with cloud, you don't have to do that. You say, what do we need right now? We don't have to worry about what we're going to grow into. As we get bigger, we'll provide more hardware. We'll build more I say hardware, but of course, I mean, we all know that it's software, but sometimes we still refer to it as hardware. Well, we'll purchase new virtual machines. We'll build new virtual machines and deploy them. It won't take long for us to do that at all. So you can think of it differently when you're having these kind of conversations. And you can say, what do we need right now? So that then you deploy it. And then back to the question, what CSP should the organization use? This is a very interesting topic and one that companies have very different reasons why they do it. Um, you know, again, the ones that I've given you, very high level, you go with Amazon if you want to do some basic work and then have a world of services available to you. So Amazon is a very, very powerful. They're always going to be the latest and greatest. I shouldn't say always, but they have up till now. When there's new products that come out, it's usually AWS doing that innovation. Azure is kind of more of the business side. It's more of your Microsoft products. It can do everything, but may not have as many services, or maybe it has some services, but they're a little bit different than the ones with AWS. If you're a heavy duty Microsoft shop, which most companies are, Azure is a natural good choice. Google, Google is really chosen for the tools. If you're using Google Earth, if you're using that data, and then Google also has some really great data products and high-end computing. So if you're wanting to look at those, then you go with Google. And of course, Oracle's out there. If you're heavy-duty Oracle database, Oracle can save you tons of money if you go through the Oracle Cloud. So different conversations and different reasons that you look for these things. All right, so now we're going to go back and talk about our cloud adoption framework. I'm not going to click on these this time because we went through these the first time, but you're not going to be asked on the exam about the specific CSP frameworks, but you need to know that there are different frameworks provided by each of the CSPs. They're all good. They all serve just a little bit different purpose. But again, you come in here and you can study this, and it's good. And I wanted to make sure that you did have this for after you get to certification. I want to make sure that you know where to go look for this information. So here's a little graphic that describes the AWS Cloud Adoption Framework. Some of the key things here: your business values, the business, people, governance, platform, security, operations, and then you have your cloud services there in the middle, tying all those things together. Azure, they have a framework as well, just as good, just slightly different and a little bit different way to look at things. Um, you can click on this again if you're going through the notes, but the Azure is more concerned with the business outcomes. What are the expected business outcomes from adopting the cloud? Collect them in a corresponding table below, organize them by priority. So, some of the things we've talked about, your stakeholder, outcome, business drivers, KPI, capabilities. Again, you can do a little more research here if you want to. All right. So, a few more things about cloud assessments. And we touched on these when we were introducing the topic. Now we're going to discuss them a little bit more using baseline. So, a baseline is a test that captures performance data for a system. For example, network administrators often establish a baseline for server central processing unit or CPU usage, random access memory usage, network throughput, hard disk data transfer speed, and storage utilization. Remember, if you hit Control Alt Delete on your computer and go into the task manager, same thing, just on the machine in front of you. These are the kind of things you would look at. So, say that if you were going to replace your laptop, the machine in front of you, you go in and you were doing, you wanted to see how much storage you're using, how much CPU you're using, how much RAM you're using. And then you go purchase a new machine, you come in and you do the same thing. You have that baseline. You could speak to how much faster your new computer is compared to your old computer. So same thing with virtual machines. You want to measure what it looks like in your data center today. And then once you get your cloud environment built up, take another look and you have your baseline, you know how much better, or in the flip case, how much worse, but more than likely you're going to be better as you're building these things out because you're not going to stop until you are performing better. But these are the things that you look at in your baseline. Next thing, running feasibility studies. Do the future requirements require the cloud? Does the company have the ability to migrate to the cloud? What capabilities can and should be offloaded to the cloud? What are the compliance needs? What are the migration path? So lots and lots of things that come out of these questions. Um, again, let's take a little step back here. Do the future requirements require the cloud? You want to make sure that what you're doing, you're building for the future. You don't want to get yourself in a situation where you built something that's not maintainable or something that you didn't need. You want to make sure that everything you're doing today is what's going to put you in a good position for 5 years from now. Does the company have the ability to migrate to the cloud? You want to make sure that you can't just lift and shift. I mean, the CSPs will sell you on options and they might even help you do that. But you want to make sure that you have the people working for you that can help you and that when you do migrate things to the cloud that you're doing it in a way that makes things better. You do not want to move to the cloud and do things that are not efficient, not effective, and mess you up. And if you don't have the right people there, you can actually do that. So it's not a magic wand. You have to know what you're doing. Lots of strengths moving to the cloud, but you got to make sure you have the right people. What capabilities? Um, this is very key, especially if you're thinking about services. If you're wanting to move into a situation where you're going to replace some of the stuff you used to do with people and machines in your data center and you want to reuse services, you want to make sure that you make good decisions and move those over in a way that will benefit you. And then compliance needs, so many things around compliance needs. The good news is moving to the cloud, you can get some help with most of your compliance needs. So if you are running things and you have government work and it needs to be FedRAMP certified, um, the CSPs will help you do that. One little caveat there, this goes back to the which CSP do you want to use? Um, Google does not have a government. They have people they have government titles, but there is no difference between Google commercial and Google government. This is going to keep some of the government agencies out of Google. So kind of an interesting one, and just one I'm going to throw out there is that's another conversation that you would have as you're making these determinations. But then compliance needs, if you have PCI, if you're taking payments via credit card, you can use the CSPs to help you with that. And then, of course, our migration path. Um, how are we going to do this? Do we want to do it all at once? Do we want to do it a little piece by piece? What is our plan for how we're going to do this? Another thing that you might want to do here when we're doing this is conduct a gap analysis. So this is where we use the baseline and feasibility studies to contrast and compare and prioritize the allocation of resources, identify technical features left out, determine capability issues, identify policies or regulations. So this is a little example here in figure 3.4 of what a gap analysis template looks like. So, we have our business people, governance, platform, security operations, and then we have our current state, what our goal is, our actions needed, priority, owner, and then the due date. All right, a few more here. We have some using reporting to identify metrics. So again, we were talking about hitting Control Alt Delete on our computer and seeing what those metrics were. Same type of thing here. We want to measure what our compute metrics are, network, storage, and services. And then the last thing here on the slide is understanding benchmarks. We want to know, our availability, the response time, the incident response time. So all of these benchmarks, there could be a long list of benchmarks. But in short, what it's doing is says, where are we today? And then that way, whenever we make improvements, we can go look and see how much better we are in the future than we were on whatever day we took our benchmark. All right. And then now we're going to kind of go into our creating documentation and diagrams. Again, there's no way to teach you everything on this. We're just introducing the subject because whenever you get into a company, they're going to have their way of doing things and you'll have to learn what those look like. Um, but the good news is this is giving you a place to start. So if you go into a company that has none, you'd be able to kind of come back in here and tell them what they would need to succeed. Of course, I would also warn you that if you walked into a company that had none of these, it might be a good idea to turn and run out the door, unless you're brought in to be the expert in there. And then, in which case, you can study up on these subjects and be that person to make sure that all of these things are done correctly. So, documentation is very important. Conversations with stakeholders and team members, location of all the resources and applications, owner of capabilities and processes, internal and external points of contact. So these are things that you want to make sure that you track. And a lot of companies might be guilty of saying, "Oh, everybody knows that. Oh, that's knowledge that everybody has." You don't want to allow that. You want to make sure that everything is documented because you may have new teams. People may forget. You may be in a situation where things are getting exciting and people don't remember things as well. So you want to make sure that that documentation is done well. So here are some collaboration tools. Again, we're not going to click on these links here, but Microsoft Teams. Teams is a great collaboration tool, one that I think any organization that has Microsoft products really buys into the Teams concept. People, when they first get started, it's kind of big, has a little bit of a learning curve, and people think that it's inconsistent, but it really isn't. It allows you to store things. It allows you to record meetings. And a lot of companies are now using Teams, and they're getting rid of their phones even. They don't have phones on their desk. Everybody is calling. You can put a phone number on there, and when people call, it goes into their Teams. I know that I have Teams running on my phone right now, and if somebody in my office were to try to reach out to me in the office, it would ring right to my phone, and I could pick up and be sharing a screen, sharing a camera, or just talking on the phone in no time. Slack. Slack is one that a lot of developers love. It's really handy. It's good. It's easy to work. It also works kind of like Teams. You can just spin up a room and be in a room with one or two people or a multiple people. So Slack is a good one. Flock is another good one. Time Camp um, Planner is a good one, and then that last one there, I haven't used it, but all of these are really really good. They're just way to collaborate in things that you can use to make sure that not only are you collaborating and communicating, but you're also documenting things as you're going. All right, just a little as a reminder here. So, for the exam that we're studying for, the Cloud Essentials Plus exam, we need to know how to use the appropriate cloud assessments given a scenario. So, be familiar with the following: current and future requirements, baseline, feasibility studies, gap analysis, business and technical, reporting, compute, network, storage. Those are the types of things that you're looking at. Benchmark, documentation and diagrams, key stakeholders, and point of contact. So I like that slide there because if you don't, um, if you go through there and you don't remember one of these, go back a few slides and review that, and then also read in the book. Okay, so that was our first section. Now, our second section in here is understanding cloud services. So, cloud services are pretty remarkable addition to your environment whenever you do move into the cloud. So what's great is you already walk in the door and you have everything you had in your data center. Remember, if you got compute, you got storage, you got networking, you already have all the things you need. And then you add this thing called marketplace where you can go purchase software, pay for it right along with your cloud. Um, and so what's great about this is whether you're a small company starting out and doing something that might be a little bit beyond your capabilities, or you're a large company and you're doing stuff that you know how to do and you did it every single day and it's no big deal. Being able to purchase this software and purchase these services from the CSP and utilize them within minutes is tremendously helpful. It's so much cheaper than going out and trying to, instead of going out and getting a bunch of vendors to come in and show you their stuff, and then you train people and you learn how to use it. You can just install it, try it. If you don't like it, get rid of it. So there's so many great things about these services. So some that we're going to talk about: IAM, or identity and access management, multi-factor authentication, single sign-on, federation, cloud-native applications, microservices, containerization, data analytics, artificial intelligence, machine learning, digital marketing, Internet of Things, blockchain, subscription service, collaboration, and VDI. So this is kind of the index of what we're going to go through here over the next few minutes. First of all, IAM, Identity and Access Management. You want to know it by its acronym, IAM. That's how most people refer to it as. And what it is it's how to access the system, who can access the system, and then what they can do once they're in there. So essentially, if you open up your CSP and you go right into the identity and access management, starting out, you could create a user, and then you can create groups. You can put users inside groups, and then you can create these policies and assign those to the groups. So, like, let's say we have an admin group and we have 10 employees and we assign 3 of them into the admin group. 3 of those employees can do everything that they need to do from an admin. Or let's say that you have groups of people that are only supposed to be able to create storage buckets. You can create a group that then give them the policy that they can only create storage buckets. And then you assign that out to people. And now only a few people are allowed to create buckets. So that's the way you start out. But then as you get more advanced, you can use your IAM, you can federate it, you can have it attached to your Active Directory so that all of that information about the people and what they're allowed to do is outside of the system, but it gets fed down into the system. So it's a good way, it's after you get started and get advanced, um, there's more advanced ways to do that. All right, multi-factor authentication. Um, it's something you know and something you have. So we're all getting more used to this. 6 or 7 years ago, a lot of people didn't quite understand what multi-factor authentication is. Nowadays, everybody knows because everybody signs into like their bank site. It's going to say, hey, we're going to send you a text to your phone and you need to know what it is. So what that is saying, even if somebody got your password, they don't have your phone and know your password. At least you hope not. So um, multi-factor authentication, something you know, a password, and something you have, a token, your phone, some other thing. And then it's beyond that, something you have, it's also somewhere you are, something you are. So some examples here, PIV cards, tokens, phones. Here's a picture of the old style of token that people used to have on their keychain. Had this number, it would count down, it would change. But now, for the most part, we don't do that anymore. We do more things with um, our phones and our soft tokens. But anyway, this is kind of where it started. Now, since we all have our phones, it's a little bit easier to do it that way. All right. The next one, single sign-on. SSO or single sign-on gives users access to all systems using one username and one password. So, um, this is think of it like how you sign into Facebook on your computer, and then you go to your phone and you sign into Facebook. It's the same username and password. And then you go to the Messenger app. It's the same username and password as your other. So it's a couple of different applications using the same password, username and password. And then when you get into IT systems, that's just from a consumer view. When you get into major systems, you might SSO might cover you through hundreds of systems, may give you access to every single system in the company, and you sign in with the same username and password. That way you don't have dozens and dozens of username and passwords are floating around. All right, I've already kind of talked about federation, so now we're going to talk about it a little bit more. This is around the identity and access management. So remember, I told you that you could sign in at first and just create users and put them in groups, but then eventually you're going to want to not manage that inside the CSP. You're going to want to do it with your enterprise level security. So you're going to want to tie it into something else. So some of the examples here: Microsoft Office 365, federated identity management, and then also our Active Directory. This is where we have our users, groups, and roles. Some applications were developed with cloud concepts and would not exist outside of the cloud. So some of these that we're kind of thinking of, these are things that came around because we're in the cloud. Now, I would argue that microservices came around a little bit before the cloud because what we were doing is we were building service buses. And so we were separating the request for some pieces of information and the retrieval of that information. So we were doing that prior to cloud, but then when you get into cloud, it just makes more sense to incorporate it. So what these microservices are is they're little bitty pieces of code that run whenever you want them to run, and they do perform some kind of function. So an example might be like a phone number lookup. Say that you have 10 systems and they all need to look up a phone number. You don't want to rewrite that code in every one of them. So what you do is you call a function. This is go get phone number, and we call it a microservice. So then whenever your application calls that service, that service kicks off, goes and grabs the phone number, brings it back, and then passes it back to your application. Another thing that we've started with cloud is the containerization. And it is just like it sounds. It's where you put things into containers. Now, I say it's that easy from a business perspective. That's all you have to know. From an IT perspective, there's certain ways that you have to write things, and you have to know what groupings you can do and what things you can put inside containers and how they're going to work. And then when you instantiate multiple containers, how that's going to work. So I'm not trying to say it's easy, but really the definition is easy. It's putting multiple things into one container so that if you ever have to duplicate that container, like if you have a web server and an application server, you could have them in one container. And then whenever you need to duplicate them, you could easily do that. And I'm talking about whenever, like if you have 5 users, you have one set of systems running, 10 users, you have to spin up another, 3 users, you spin up a third, I mean, 30, you spin up a third. And then at the end of the day, when your users start falling off, you start pulling those systems back and you go from 3 to 2 to 1. These are the types of things, and containerization makes that work a lot better for us. All right, some things here about our microservices. Monolithic applications used to be part of the same file. These were broken into smaller components. So again, kind of back to that example I was talking about. You have your microservices sitting out here, and they're ready to run. And so, like, let's say this microservice right here, its job is once you send it a name, it returns a phone number. So right here, it's all just sitting here ready to go, ready to go. So you have this, here's your application running over here. It hits a business logic and it says, I need a phone number for Jeff. So it pops over here. This microservice here tells it where it's going to run, and it throws it over here and it says, go get this. This guy was waiting. It goes and grabs the phone number, returns it, boom. It hands it right back to the calling application. All right, and then our containerization, I'm just kind of describe that just like it sounds. Items are being placed in a container. Again, here's a video. If you don't get it yet, here's a video to let you know how that, to give a little bit deeper explanation as to what containers are. All right, now we have one of my favorite Dilbert cartoons. The boss says, I need to know I need to know why moving our apps to the cloud didn't automatically solve our problems. And then Dilbert says, you wouldn't let me re-architect the app to be cloud native. And he says, just put it in containers. And he says, you can't solve every problem by just saying techie stuff. And then the pointed hair boss goes, Kubernetes. Again, Kubernetes is one of the containerization applications. There's a few out there. There's Docker's, Kubernetes, but that's pretty standard. I like that cartoon because it tells the truth. A lot of times business owners come in and they're saying, we moved to the cloud. Why isn't it cheaper? We moved to the cloud. Why isn't it faster? Well, you didn't do all the things you had to do to make it that way. All right, now we're leaning more into the data analytics side. Again, remember, we're going through services. We've been talking about identity and access management services, and then we talked about container services, microservices. We're going through a long list of unrelated services here, but they're all concepts that you do need to know. So first of all, what is the difference between a database, data warehouse, and a data lake? So well, let me tell you here, there are so many database services out there, probably more database services than any other, because through the years, we would have to hire people that understood databases in order to keep our applications running. And a lot of what we were doing, we were just using relational databases, and they were good and they're fast and they still have a big need, but there are so many more types of databases that we need. And also, for years and years, we've been hiring database analysts and people to manage our databases when they don't they can't stay busy doing that all the time because it's not a 8 hour a day job all the time. Now, if anybody's a database analyst, I'm not trying to put down the importance that they play a very important role. But we do look at this, and our cloud service providers are like, look, if you're tired of relying on people working on your database and you would like for us to manage your databases, come in here and we will implement an RDS version of the database and let you just come in and use it. So they've kind of automated that function. So then now we're talking about different types. So I have a video here of what is the difference between database, data warehouse, and data lake. So how data and analytics started, organizations were in silos. Okay, so here's my definition here. We used to have every application would have its own database. And so then there were people that wanted to say, hey, you know what? If I took stuff out of this database and stuff out of this database, I can do a deeper understanding of some business analysis around the database. But what we found is if we allowed people to dig into our databases, they would slow the databases down. So the first step is like, hey, let's quit doing this during the day. Let's do this at night. But then people started coming around in the mid 90s and said, what if we started doing these data warehouses? And what this means is at the end of the day, we take all the data from our databases and we move them to a centralized location. Then the people that are doing the analysis on that database could hit it all day long. They could just beat the heck out of that database because we don't have production people and production users on that database. So that's, to me, and at least in my experience, that's how I saw the advent of a data warehouse. And then years later, and mainly when we go into cloud, we started talking about these data lakes. And what data lakes are is like data warehouse on steroids. It's thousands and thousands of databases and data warehouses. Their data is all thrown out there into the data lake, and you can do machine learning on it. You can do your own analysis on it, and you can start pulling data in. So, one of the best examples I can think of on this, when I was in college in the 90s, I remember I had a teacher that was talking about the timeliness of data. And he said, we have a system that can 100% accurately predict the weather for tomorrow. Problem is, it takes 48 hours to crank the data, meaning we never can tell you what the weather's going to be like tomorrow. We can only tell you what the weather's going to be like yesterday. And this is a real live example of things that they did. But now, you know, our weathermen and women are not nearly as far off as the old ones were because they have these models built and their computers are giving them better information, and we have sensors out there and they're gathering all of that information. And so that's one thing that government, USDA, Google, Amazon, they all work and they provide farmers and other people with better, more accurate information on the weather, what it's going to be like today, what it's going to be like tomorrow, what the entire season is going to be like. And this would not be possible without having these data lakes with all of this information that gets fed in and the machine learning that goes in to figure out what to do with that data. All right, and then data analytics. So we kind of progressed where we are today. This is what I was kind of jumping into. We can use our artificial intelligence to come up with better data and to know what to do with that data much better than we ever have in the past. And so besides practical uses like that, we also have like our virtual assistants, video games, digital marketing, financial industry, transportation industry. So lots and lots of things that we do because of the abundance of data that we have. All right, and I've already touched a little bit on machine learning, but machine learning is a little bit different in AI. In AI, the machine needs to be programmed to respond to stimuli to complete a task. But with machine learning, the idea is that the data can be fed to a machine and it will learn from it and adapt. So, machine learning is a specialized form of AI. Things that practical uses here: facial recognition, speech recognition, medical diagnosis, financial modeling, prediction models, data extraction. There's really no end to what we can do with machine learning. It just gets better and better and better. Some other things that we do with our cloud services is digital marketing. So, like for email campaigns, social media like YouTube, Facebook, Instagram, Twitter, X, Pinterest. So, why? Better customer engagement and response, real time results, and enhanced analytics, campaign automation, and lower cost. So, I think we've all been exposed to this. Sometimes we look over and there are ads, and you're just thinking, I wonder how they knew that I was looking at a weight bench. You look for a weight bench in one area, and now it's over and on the ads running on your Facebook. Different things that we can do with that. Internet of Things, as I've told you guys before, this is one of my favorite subjects because I feel like there's still so many untapped things out there. But Internet of Service, remember, if you don't remember that definition, it's giving an internet presence to a real world item, such as the example I gave you, my garage door. I have my garage door hooked up to the internet. The internet knows if my garage door is open or if it's closed. I can look on my phone, and if it's open, I can send a signal to have it closed. If I want it open, I can send a signal to have it open. So some other uses: home entertainment systems, security systems like garage doors, like I just said, heating and cooling, home appliances, modern cars, fitness and health monitors, commercial, medical devices, transportation, infrastructure. So, a little bit more on the Internet of Things, potential issues, standards and governance, data security and privacy, data storage and usage. Um, and then the next thing I had on here is IoT new ideas. What are some ideas that have not been developed yet? And as I've told you before, I used to run some college exercises where I would tell people, let's come up with ideas that have never been thought of before, but I wouldn't tell them it was a joke or that I wasn't serious. But I just wanted to see if a group of people could come up with new ideas. It's a very difficult task. And there's been a few times that I thought that I was in a class where people thought of an original idea, something that had not been done before, and then go do some research and find out, whoops, well, that one somebody else has done before. But you never know. And I do feel like there's still so many ideas. As a matter of fact, I know that there's a couple of companies in town in Kansas City, at least a couple, probably more than that, that help people who have ideas specifically around Internet of Things, help them write the code behind it for a partial piece of their profits. And so if there's companies out there making money on that, I know that every day people are putting out really good ideas. One of the very first Internet of Things I'd ever heard of is I used to work with a guy that worked for Caterpillar, and he said that they put things in their bulldozers and in their front end loaders that would not allow the device to dig when there was a mat cable, like fiber cable, gas line that was in there. So they were utilizing that technology back in the mid 90s. It's probably really perfected now so that these people would not be able to cut into something that could hurt them or disrupt service of utilities. Blockchain, I've told you before, I kind of understand blockchain, but then it eludes me. But simply put, it's defined as an open, distributed ledger that can securely record transactions between two parties in a verifiable and permanent way. You may or may not have heard about blockchain, but it's likely you've heard of the most famous example of blockchain in use, which is Bitcoin. So I do have a couple of videos here you can watch. I have a 7-minute video, an article about it, and then also a really long video that goes into great detail about what blockchain is. Again, we're talking about services. So all you need to know is that blockchain is one of the services. So blockchain principles, decentralization, no one owns blockchain, no, not centrally located, transparency, everyone in the blockchain has access to all the data and it can't be tampered with. And then immutability, it's unchangeable. It's a ledger that cannot be changed. All right, I'm going to skip over this for now. Okay. Now we're talking subscription services. So think about the big four. And again, I talk back and forth, and I really should just say big three: compute, storage, network. But a lot of books put databases in here as well. So we'll say for now, think about the big four: compute, storage, network, databases. These are everything you need to replace a data center. So everything else that a CSP offers are services. So their services are offered in two different ways. Their subscription services mean I'm going to pay for a certain level and I can use as much as I want. And then there's pay as you go, meaning I'm going to hook up to the service and every time I use it, I will pay for it. Some examples of this are Office 365 and Google Docs. You get a free subscription service with both of these, but then if you cross over a little bit different level, then you're going to pay a little bit more, or you're going to start paying for the service. And then if you go a little bit higher, you're going to pay even more. All right. So then now we're going to move on to our collaboration. Again, we're talking about services. Always important, but as firms go global and more people work from home, collaboration software is more and more important. So some of the things we do with our collaboration, we share files and we share storage, do a lot of video conferencing, online chat, task management, real-time document collaboration. Microsoft Teams is on the bleeding edge of this. As I said, I'm a big Teams fan, and it's really, I have teams out there that manage entire projects using the Microsoft Teams suite, because you can also have these. When you create a team, you can add people, then you can create folders. You can give access to folders to just certain number of people. You have OneNote where you can put notes out for everybody on the thing, on the program, on the project. And then you can also use some third-party tools to actually create boards to manage your projects and to be able to show everybody where you are in the project. So a lot of collaboration items, and Teams tries to bring all of those together. Right. Another huge service that's getting bigger and bigger, virtual desktop. Um, Several things that are great about virtual desktop. First of all, it's been around since 2006, older than the cloud. I would argue it might be a little bit older than that. But some of the benefits: desktops are managed centrally, security is increased because nothing is shared locally, less hardware. So I've talked about a few use cases. So let's say that at the end of the year, I have a lot of people that are returning products wanting to go hire about 500 people to take phone calls. Back used to, we would have to ship out 500 laptops. The users would be out there, they would get the laptops. There might be some problems, they had to send some back. And we had all this equipment and stuff being mailed and out there. And then at the end of the season, you have to get everybody to send that equipment back. But what's great is, and again, this is just one use case: virtual desktop. Say I have a bunch of people that need access to systems. Tell them to use their own computer and sign into the desktop. They all have access to a desktop. It looks just like a brand new computer. If there's a problem, I can fix it. I can blow their VDI away and create a brand new one. And they're only out a few minutes. They didn't have to ship some piece of equipment back. So lots and lots of good use cases. Let's say that there are people out there, and some of them have nice big computers. Some of them just have an iPad. It doesn't matter. They can run their virtual desktop right there. It looks the same, and it allows them to be able to access and be just like they're on a desktop, except you don't have a bunch of laptops floating around. You don't have to worry about people picking things up and running off with them. So again, virtual desktop, things that I think will get bigger and bigger, and I think that we'll even approach into the consumer market, where I'll have a much less powerful computer in front of me, and I'll sign in and use my own, and I'll pay for it when I want a really good computer. And when I don't, I'll just use my, like, let's just say an iPad. I just need a web browser for a while. I'm just doing a few things, but then I need to really do some compute. I'll sign into a desktop, do that, and I'll only pay for it when I'm using it. All right. BDI, how it works: hypervisor and virtual machines. VMs are hosted on that hypervisor. Connection broker managed security access. So here we have our connection broker. Here we have our phone, laptop, or desktop. These are the people that are out using it. Then here we have our hypervisor, and then we have our virtual desktops running on top of this. All right. So in summary here, we talked about two major sections. Talked about our business principles of the cloud, talked about our cloud assessments, then our cloud services and benefits. We talked about machine learning, AI, Internet of Things, Bitcoin, VDI, lots of business type of conversations going on in this chapter. Okay, so now we're going to do our exam essentials. Remember, the exam essentials kind of like our flashcards. It's a way for us to study the material, and it's also a great way for us to identify anything that we don't understand if we need to go back and reread it. Right. So, first one here: understanding the benefits of cloud native applications, microservices, and containerization. Microservices and containerization are designed to improve the speed of software development and also lower cost. Microservices break down a supposed to say monolithic program into smaller components, which are independently coded and managed. Centralization is a way to store all items needed for a program in one contained location. Know how to gather current and future cloud requirements. So the best method is to talk to key stakeholders who are important people within the vested with a vested interest in how the cloud will work. Ask the right questions and understand the time horizon for when changes should be implemented. Understand what baselines are used for in cloud assessment. So, a baseline is a test that captures performance from a system. For example, cloud baseline, normal network throughput, or CPU utilization. Know how a feasibility study is used in cloud assessment. So, feasibility studies are used to determine the practicality of a proposed move to the cloud services. If it gets at questions such as do the company needs require the use of cloud, and does the company have the ability to migrate to the cloud? Understand what gap analysis does. So, a gap analysis identifies where the network and the organizations are now and what needs to be true to get them to where they need to be. Gap analysis focuses on business and technical readiness. Reporting can help determine baselines for current network performance. If you already have cloud services, the CSP will provide reports on resource usage, such as compute, network, and storage resources used. Understand how to use benchmarks for cloud assessment. So, a benchmark is a standard of performance or a point of reference for comparison. For example, if you have a baseline um, read of your CPU utilization, you might know whether it's good or bad. A benchmark can help you determine that by comparing your data to a known standard. So I think I said you would, but you might not know whether it's good or bad. So you use the benchmark to compare it so that you know. And then you're also not just using your own opinion, you're using facts. Know why it's important to create documentation and diagrams as part of the cloud assessment. Cloud environments can get really complicated. Document conversations with key stakeholders and potential CSPs so you know what decisions were made and what the next steps are. Document and diagram layouts of where services will reside so a new business and analyst, network administrator, a new business analyst or network administrator can look at them and understand how your cloud setup works. Know who key stakeholders and points of contacts are. So, a key stakeholder is someone with a vested interest in the cloud project. The cloud can be an executive, such as a CEO or CIO, or even a cloud user. A POC is someone who is responsible for managing communication between company and the CSP. Remember, POC is point of contact. Know what SSO is? So, SSO is used when users can access multiple systems or resources through a single initial login. Know what MFA is? So, multi factor authentication occurs when a system requires multiple pieces of information to authenticate a user. For example, in addition to the user's password, which is one factor, the system might require a PIN, one-time password, security code, or answer to a security question. Remember, multi-factor authentication is something you know, and then something you have, or somewhere you are. It uses more than one form of authentication. Know what federation is? So, federation is much like SSO, but it applies across multiple corporations. It's when multiple companies' security systems trust each other to validate users. When users are validated by one, they can access resources in another federated security domain. Understand the benefits of cloud native applications, microservices, and containerizations. So, microservices and containerization are designed to improve the speed of software development and also lower cost. Microservices break down monolithic program into smaller components, which are independently coded and managed. Containerization is a way to store items needed for a program in one contained location. Understand three areas of data analytics. There are three areas you need to know: machine learning, artificial intelligence, and big data. Know what big data is? Big data refers to unstructured data sets as opposed to structured data sets such as relational databases. Know what AI is? So, artificial intelligence is when machines are programmed to perform smart human like activities. Understand what machine language is and how it differs from AI. Machine learning is when data can be fed into a computer and it will learn from it and adapt. With AI, the computer and machine only respond to input as it's being programmed to respond to. With machine learning, the computer or machine can take novel input and respond to it based on feedback. Was it right or wrong? It can learn and adapt to future input. Know what digital marketing is and two common ways it's executed. Digital marketing is the attempt of selling of products or services using digital technologies. Two common methods are email campaigns and social media posts. Understand what anonymous environment is. An anonymous environment is a computerized environment where complex human actions are mimicked without human intervention. Examples include self driven cars and robotics manufacturing facilities. Know what IoT is? So, the Internet of Things is a network of devices that are able to communicate with each other and exchange data. Common applications include home entertainment systems, security systems, heating and cooling systems, home appliances, modern cars, medical devices, and manufacturing, transportation, and infrastructure systems. Know what blockchain is? So, a blockchain is an open distributed ledger that can securely record transactions between two parties in a verifiable, permittent way. It's a technology behind Bitcoin, but it can also be used in other types of transactions. Know what a subscription services are? Know what subscription services are? CSP will often sell their services or subscriptions as services, which means you pay for the services for a period of time, such as 6 months or a year, and often at a discount versus a pay as you go model. Understand the cloud and how it can help you collaborate. So there are dozens of cloud-based collaboration software packages which allow users to share, edit files in real time, video conference, chat, and manage tasks. Know what a VDI is? So a virtual desktop infrastructure. User desktops reside inside of a VM located on a server where users can log into their virtual desktops from any location with an internet connection on any type of device. Know how clouds implement self-service. So the CSP will have an online management interface where the client can acquire and use additional services without intervention from a CSP.